This is Pat Baker, and we're going to take a look at your multiplication table programming assignment and hopefully give you some strategies for tackling this program. So first of all, let's take a look at some output, and I've got it on the slide here. Multiplication table is really just a way for students to practice their multiplication facts. So the way it works is if you have a multiplication table of size 3, it would look like this. This is what you'll be generating in your program. And how it's used is that you multiply 2 times 3, and the answer will be the intersection between the row and the column, and in this case it's 6. So if we look at the next table, we can look at another example. So if you were learning your multiplication facts and wanted to know what 4 times 3 was, you could say 4 times 3 is 12. Or if you're learning your multiplication facts all the way up through 5, you could say, what is 5 times 2? So 5 times 2 is 10. So this is your goal. You're going to be creating this multiplication table, and you're only going to allow the users to put in a table size of 1, 2, 3, 4, or 5. So let's take a minute now and pull up the existing code that you're going to get when you download the skeleton. Okay, so this is our code we're taking a look at, and let's run it. This is the code that you're going to be downloading, and see what it generates. So it asks us for a table size, so let's put in 3. That seems to be the example we're working with. So 3. And you'll see that so far it generates the top part of your table. And your goal is going to be to create the rest of the table. So let's go back to our slides and take a look at some strategies. All right, so here we are. This is just some pseudocode to have you work on step number 1. So you've already got the verbiage that's in purple has already been done for you. So in the code, the skeleton code, you're already prompting the user for the table size. And your next task is to generate the multiplication table. Well, that really is 2 parts. You're generating that horizontal header, which has already been given in the skeleton code, and you've got to generate the rest of the table. So if I go back and look at our previous slide, you've been given this top part, the numbers and the dashes, and you're going to be generating this area in here. So in all these tables, you're generating this area here. That's your first task in there. So let's take a look at what the pseudocode says, because really this is all it is. So at this point where in your code it says generate the rest of the table, this is what you're going to do. You need a nested for loop, and based on the size, you're going to say for every row in the table, I'm going to display the row number, which would be in the first row 1, and a vertical bar, and that's actually the key above the enter key in most keypads. And then you're going to generate the answers in the middle of the table. So that essentially is the row times the column, but you're going to do that with your nested for loop. So your outer for loop and then your nested for loop. And that's going to generate that code in the middle right here. So there's your row number, your vertical bar, and then the answer of row times column, row times column, row times column. Okay, so the strategy when you're doing these more complicated programs is to get this part working. You're going to assume the user's putting in data. That's good, 1 through 5, and you're just going to generate one table and get your layout working and get that part working before you go to the next step. But the next step is to now make sure that the user's giving you valid data. So how do we do that? So here we're just going to keep working on our pseudocode. And again, you're going to prompt this is the same. I've just sort of condensed and added the parts for the data validation. So you're going to prompt the user for their table size, And then at that point, before you ever generate the table, you're going to check to see if it's a valid size. So you're going to ask the question, is the size less than or equal to 5 and greater than 0? And if it is, then you're going to proceed and generate your multiplication table, which is code you already have working at this point. Else, it's not valid, it's not a valid size, it's negative, or it's 0, or you've got some great big number, and you're going to tell the user that they've entered invalid data. So that's the next step. Once you get that going, so you should try that, see what happens when you put in a 15 for the table size. It shouldn't work. And see what happens when you put in like a -5. It should tell you you've entered invalid data. So once you have that done, then you're going to go to the very last step. And the last step is that around all of what you've already got coded, you're going to put a while loop that says, as long as the size is not 0, so you're still going to prompt the user for the table size, so you got to get an initial table size. And if it's not 0, if it's any other number, then you're going to check to see if it's valid, and you're going to go through your code. And at the very end of this while loop, you're going to prompt for another table size, and you're going to come back up, and as long as that's not 0, you're going to go through this loop, and you're going to stay in this loop until the user puts a 0. Because once the user puts a 0 in here, then this will evaluate to false, because the size will now be equal to 0, and you're going to get out of that loop and display done. And really, that is all there is to this program. So now I'm going to run the complete code so you can see its execution. Okay, so here we go. We are in a complete, this is the solution, and let's see how it works. So you're going to ask the user for a table size. Let's go ahead and put in a valid one, 3. It essentially just checked to make sure that 3 was good, which it is, and then it generates the headers right here, which was code already given to you. You generated the guts of the table here, and now at the end of your loop, you're asking again for another table size. So let's put in a number that isn't good. So let's put in 15. It reads 15, and it says that's not a valid size, so please enter another number for the size. So I'm going to put in a negative number, -4. That shouldn't be valid, and it's not. So let's enter a valid number. Let's put in a 2. Okay, and there's our table. And now I decided I'm going to quit, so when I'm putting in a 0, it's back up at that while loop saying, is the size not equal to 0? Well, the size is 0, so it will be done. So let's go back and look at that last slide of pseudocode, and now that you've seen the program run. Okay, so now after you've seen it run, again, let's just go through this again. You're going to prompt the user for the table size initially. You're going to check. As long as it's not 0, you're going to enter this loop and check to see if it's a valid size. If the size is valid, in other words, it's 1, 2, 3, 4, or 5, you're going to generate your multiplication table. Otherwise, you're going to tell the user that they inputted invalid data, and you're going to ask them again for the table size. It's going to come back up, and as long as it's not 0, it's going to go back through the same thing. So let's say they put in a -4 here. Come back up. Well, that's true. It's not 0, but this isn't valid, so it's going to come down here and tell the user they entered invalid data, prompt them for another table size. Now they put in 0. Well, size is 0, so this evaluates to false, and you're going to display done. So really, that's all there is to this code, and the way to tackle it is to get each section working before you go adding the next feature.